Okay, an exponential function is any function that can be written in the form. Okay, I'm going to use f of x equals a to the x. And we would say it has base a. A is a constant, but there's certain restrictions on it. So we're going to require that a be bigger than 0 and not equal to 1. If a is a negative number and x is a counting number, the exponent's a counting number, then it flip-flops between positive and negative, right, if a is negative. Because if you have an even counting number for x, it's going to be, and bring a negative to an even number, it's positive. If it's odd, it'd be negative. That's confusing. So we avoid that situation by just saying, hey, a is bigger than 0. Also, why would it not be interesting if a is equal to 1? 1 to the x is just 1, right? Okay. So those are kind of natural restriction. So any function of that form is an exponential function. So long story short, the variable is in the exponent if we're talking about an exponential function. Do you think it's particularly hard to evaluate these things? It's not bad. Let f of x equal 3 to the x, and it will turn out to be a function. It will pass we're going to graph one of these in a minute. You'll see that it passes the vertical line test. F of x equals 3 to the x. What's f of 2? Function notation hasn't changed, so what am I going to do with that 2? Plug it in for x right here, so 3 squared, 9. Right? I got to remind you what the negative means. So g of negative 4. So g is 1/2 to the x power. What's g of negative 4? It would be 1/2 to the negative 4. What does the negative mean? How do we get rid of the negative? It just means take the reciprocal, doesn't it? So 1/2 to the negative 4 is the same as 2. The reciprocal of 1/2 is 2. 2 over 1, if you like. You don't need the over 1 part, to the positive 4. And that's 16. 2 to the 4th is 16. So for f, if the input is 2, the output's 9. For g, if the input's negative 4, the output is 16. So function notation, it doesn't hurt to review that because we're getting close to final time.